is Hafiz Abrar Ahmed, and today I am going to discuss about the soil gel synthesis bomb. Key concepts: in organic material synthesis, ceramic method shake and bake, ceramic method synthesis of yttrium barium copper oxide, soil gel. In organic material synthesis, solid state reactions, solid solid, solid gas, decomposition reaction, and gelation. Ceramic method shake and bake. It is the direct reaction between two or more solids to form the final product. In principle, no decomposition is involved. Solid-solid reactions are simple to perform. Starting materials are often readily available at low cost and reactions are clean. Don't involve other elements beneficial for the industry. Solids don't react with solids at room temperature even if thermodynamics is favorable. For example, high temperature needed. Disadvantages include the need for high temperatures, the possibility of inhomogeneity, contamination from containment. Ceramic method synthesis of yttrium barium copper oxide. It is the direct reaction between three solids components: yttrium oxide, barium carbonate, copper oxide. The first step is the grinding to obtain large surface area. The grinding particles are pressed into pellets, and the final step is to heat in an aluminum board, and the temperature profile is given below. Chemical mixing in solution. Decrease diffusion lengths by using intimately mixing of cations, solid precursors containing the desired cations. Precursor for ceramic synthesis. Precursors via co-precipitation. Precursors via solid solutions and compounds. Not so suited for preparation of yttrium barium copper oxide. Soil gel methods. The soil gel process may be described as the formation of an oxide network through polycondensation reaction of molecular precursor in a liquid. A soil is a stable dispersion of colloidal particles or polymers in a solvent. The particles may be amorphous or crystalline. An aerosol is a particle in a gas phase, while a solid is a particle in a liquid. A gel consists of a three-dimensional continuous network which encloses a liquid phase. In a colloidal gel, the network is built from agglomeration of colloidal particles. In a polymer gel, the particles have a polymeric substructure made by aggregates of subcolloidal particles. Generally, the soil particles may interact by van der Waals forces or hydrogen bonds. A gel may also be formed from linking polymer chains. In most gel systems used for material synthesis, the interaction are of a covalent nature and the gel process is irreversible. The gelation process may be reversible if other interactions are involved. The idea behind soil gel synthesis is to dissolve the compound in a liquid in order to bring it back as a solid in a controlled manner. Multi-component compounds may be prepared with a controlled stoichiometry by mixing salts of different compounds. The soil gel method prevents the problems with co-precipitation, which may be inhomogeneous. The gelation reaction enables mixing at an atomic level, results in small particles which are easily sinterable. The sol gel method was developed in the 1960s mainly due to the need of new synthesis methods in the nuclear industry. A method was needed where dust was removed and which need a lower sintering temperature. In addition, it should be possible to do the synthesis by remote control. If the gel is dried by evaporation, then the capillary forces will result in shrinkage. The gel network will collapse and a zero gel is formed. If a drying is performed under supercritical conditions, the network structure may be retained and a gel with large pores may be formed. This is called an aerogel and the density will be very low. A record of less than 0.005 gram per centimeter cube. Sol gel methods. The sol gel process a change from a liquid state to a gel state through condensation reaction. A sol is a stable dispersion of colloidal particles or polymer in a solvent. The particles may be amorphous or crystalline, typical size few nanometer. A gel consists of a three-dimensional continuous network of the sol particles, which encloses a liquid phase. In colloidal gel, the network is built from agglomeration of colloidal particles. In a polymeric gel, the particles have a polymeric substructure made by aggregates of subcolloidal particles. Sol gel method. Precursor usually mixture of metal bimetallic or bimetallic alkoxide. The step 1 is the hydrolysis and the second step is the condensation, and the precursor converted into sol. Upon condensation and agglomeration, the sol converted into gel. During gelation, covalent bonding, van der Waals and hydrogen bonding are formed particulates ions. Gelling via agglomeration, common polymeric sols. Gelling via condensation. Sol gel may be used to prepare material with a variety of shapes such as porous structure, thin fibers, dense powder and thin film. Sol gel method. The sol gel process may be described as formation of an oxide network through hydrolysis and polycondensation reaction of a molecular precursor in a liquid. Sol is a stable dispersion of colloidal particles or polymers in a solvent. Gel consists of a three-dimensional network which contains a liquid phase. Sol gel method. Solution. Organic compounds of elements alkoxide, ester or inorganic salts, nitrates, chlorides. Solvent. Usually alcohol, methanol, ethanol, water. Catalyst of chemical reaction. Sol gel method. The basic chemical reaction. The first step is the hydrolysis and the second one is the polycondensation reaction, and that chemical reaction is given. Sol gel method. Basic physical transformation. Solution give rise to sol on giving 40 to 250 degree Celsius temperature, drying, evaporation of water and solvent. Sol give rise to gel on 250 to 400 degree Celsius, oxidation of organic matter, and the gel give rise to solid body upon giving 400 to 1000 degree Celsius temperature, removal of OH group, densification. Application of sol. Sol give rise to sol fibers, powders, and by gelation evaporation it give rise to zero gel film, and zero gel film upon heating give rise to dense ceramic film. Sol give rise to gel, and gel upon solvent evaporation give rise to zero gel and zero gel upon dry heating converted into dense glass. Gel upon supercritical extraction gave rise to aerosol gel methods. Multi-components compounds may be prepared with a controlled stoichiometry by mixing salts of different elements. Direct mixing of elements to form one salt directly. Mixing at atomic level through salt formation. The salt gel method prevents the problems with co-precipitation, which may be inhomogeneous, results in small particles which are easily sinterable. And the flow chart of photosensitive yttrium barium copper oxide precursor salt is given.